Right now we have an Arduino Nano connected to a NeoPixel strip here, right? We're using pin 11 and we have 11 pixels. So in our code, we have pin 11, right? And then 11 NeoPixels. And we created a strip called Adafruit NeoPixel. This is NeoPixel 220, or sorry, NeoPixel 120 NetWriter. And so what we're going to do is make the lights turn on back and forth, just go side to side. It's called scanning. It's going to start here, come up here. Once it hits this point, we want the direction to go that way, right? And then it's going to go this way, hits this pixel, and the direction then goes that way, and then the lights are going to go this way. So we need a couple things for that. We need four pieces. Well, really, we only need three, but we'll put four pieces in here. So we need int. We need to know where that pixel is, the current pixel is. So I'll call it pix. We need a direction, int dir equals 1. Cool. So every time uh, it increments, it goes 1 direction of this until it hits this, then direction will equal -1. So we'll have to set up a conditional statement for that. Okay. So then let's do a long unsigned timer. Okay. And then we'll do a long unsigned. Let's see, we'll call it scan timer. Okay. So in our loop here, first thing we do is set timer. Timer equals millis. So it's going to query the board for how long it's been running in milliseconds. And then if timer is greater than scan timer, let's do a bunch of stuff. So first thing we're going to do is increment our scan timer. So scan timer plus equals 80. Sure. And then we have the actual movement of the pixel, right? So we have pix plus equals dir. So if direction is positive, if it's 1, it's going to go pixel, 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 start going that way, right? But if it's -1, it's going to start going this way. It's going to decrement each time. Okay, got that set up. And then if pix is less than or equal to 0, so if it hits 0 right here, we want it to start going that way. Okay, so if it is less than or equal to 0, let's make sure dir equals 1. Put the curly. Perfect. So if pix is less than or equal to 0, direction equals 1, which makes it go that way. If, let's see, pix is greater than or equal to LED count, then dir equals -1. So if it hits this point, well, that's not quite going to work, is it? Because LED count's 11, and we actually want to do 10. Now, I could just type in 10, but that's not very portable. So I'm going to do LED count -1. So it's going to go all the way up to 10 before it turns back to 0, turns back to 10, turns back to 0. That's the idea here. Okay. So once we got a spot for that, we can do a strip dot set pixel color, and we want to do it where the current pix is, and then we want it full red, and then no green, no blue. Okay, and then of course do a strip dot show. Now, if I were to upload this, which I'll hit and explain to you, it's not going to work right. Right? It's just going to fill this. So it's going to turn this red one on, turn this one on. It's going to keep turning them on without turning them off, though. That's the issue. Then it comes to here, and since they're all on, you don't see any difference, right? So it just got done uploading. And yep, all it did was fill it up. And I'll hit reset on the board. Hit reset, it's going to clear them out, and then start lighting them up. Okay, not very Knight Ridery, right? I don't remember Knight Rider, just turning them on and staying on. Okay, so we have to turn the previous one off. And cool thing is, we have that up here. So before it even increments up the direction, whatever direction it is, we can do strip dot set pixel color. I'm gonna do pix comma turn off, turn off, turn off. Okay, semicolon, and now we hit upload. So now it's gonna increment the time. Let's see. Oh, yeah. I wonder what his is. Oh, it aired out. Okay, good. Okay, so it's gonna increment the time 80 milliseconds. It's gonna move the time 80 milliseconds away. So it's gonna take 80 more milliseconds before timer can overload scan timer, and it can start running this. Okay, and then we have set the last one to black, and it looks like it's working, right? And then here's the direction. Go that direction unless you've been told to change the direction. That's fine. Yeah, turn it red and show. So it works now, right? But it's kind of lackluster. It's kind of boring, just going back and forth. It would be nice if it trailed some fading light. So that's what we're gonna do next. So to keep track of that, I'm gonna do an int fade, and then it's as big as LED count. That way, every single pixel can remember its value. Okay, is that all we need? Yeah, I think so. Let's give it a try. So now we need to show all these pixels, right? Don't just need to turn the one that's on. We need to show a lot of them. So I can turn this off. I can get rid of all this stuff. So we're still good here, right? All this pixel. Oh, yeah, we're still good. Okay. So let's first of all, the current pixel that we're on, instead of just turning it on, we're going to turn it on in the memory, in the fade memory. So fade, start your brace or your square bracket. Not sure what it's called exactly. Okay, fade. Let's do pix. Fade pix equals 255. So it's going to be full brightness here. Okay. So it's moving pix up and down. It's going to set whatever current one it's on to 255. So we're going to do a little for loop here. Let's see. A is less than LED count. Okay. Semicolon A plus plus. Okay. Now we can start running them off the fade instead of just turning it on, right? So we're going to do a strip dot set capital P ixel capital C other. I'm going to do A comma fade A. Oh yeah, comma 0 comma 0. I was about to copy that. That'd be just a white dimming down. Okay. So now I've got to bring the fade down every time too. So fade A minus equals, we'll do 85. There we go. Because 255 divided by 3 is 85. So it should have just a couple trailing behind it. Okay. DAE. That's not quite right, is it? It's supposed to be fade. That's far off. Nice. Fade. Fade A equals or minus equals 85. So after it's done showing it, it brings all the fade values down by 85 out of 255. So it's about a third of the way down. Still a pretty big hit. After it's done setting all the LEDs, then we do a strip.show. Okay. And then parentheses. Let's see if this works and what else it needs. So this should have some sort of trail behind it. Oh, of course I did. So, oh, I see. I was supposed to use the bracket there. Okay, let's try this for real. So currently since you have 13 or 11 neopixels, your bully has enough of a length to do mean stuff to you. All right, this just started uploading. Cool. Okay, and it's going really fast, back and forth. Probably not what we wanted. Not really. Okay. Let's see. Why is it going back and forth like that? So fade pix equals 255. That's right. So wherever fade's at. Now we know it worked a second ago. Like well. So it's gonna go through each of these, as many LED counts as there are, right? Just like fade's that same size. Oh, fade pix. Yeah, that's right. Okay. Yeah, that should be good. So ship dot set pixel color a comma fade. So turn it red and then 0 0. So yeah, we got a lot of weird noise. Let's figure that out. Okay, so under setup, strip dot begin, strip dot show. Let's do a serial dot begin at 11:5200. Okay. Next thing we're gonna do is actually, yeah, what sort of data do we want here? We know there's an issue. We just don't know what to look for. So it sets you. Oh, I see what's going on. It's setting it negative. Okay. I don't need all this. So I'm minus 85, right? So once it hits 0, it's 0. But next one is negative 85. So fade A equals max 0, comma, fade A minus 85. In the parentheses, semicolon. Let's give that a try. So now it should like minimum out to 0 because 255 is greater than 0. So it's going to be 255. And then what is that? 160? 170? Something like that. There we go. Cool. So now it has this leading trail here, right? And it's looking fine in videos, but it's still not looking quite right to like my human eyes. So even though it is trailing, which is kind of nice, we need to make it like just start fading, I guess, before we start moving so much. So now it's gonna move that pix every 255 milliseconds, right? Or every 80 milliseconds. Let's make one that updates a lot faster. So scan timer, every time it exceeds 80 milliseconds, it goes to the next pixel. Let's do a fade timer. Long unsigned fade timer. Okay. So that one's going to run a lot faster. So if timer is greater than fade timer, then let's I'm actually going to pull all this out. Pull this. I'll actually pull all this out. There we go. Should I? Yeah, I should. Okay. Control X. Control. I guess I'll hit this here. Control V. Okay. So, oh, I should also fade timer plus equals 10. There we go. So I actually increment the timer up. So I increment the timer up. Okay. And then it's going to set that pixel color wherever it's at. But it's, so this one's 80 and it's coming down to 85. So this one's 10. So it's 8 times faster. So maybe 1/8 or so. Let's do a fade of 8. Let's see what happens here. And so it's going to change all these colors and then broadcast it to the strip. Okay. So this is every 10 milliseconds. And so it's going to fade, but it's actually going to look like it's fading instead of being blocky. I don't know if you can see it on video, but I can see it. Or it just looks like it's weird. Oh, there we go. So now that's way more mesmerizing. I don't know if you can see it in the video here, but yeah, I can see it actually like incrementally turning down, which is a lot nicer. So I'm gonna speed it up though. I'm gonna see if I can get away with like, I don't know, 5 or something. 5, 6, 7. No, we'll go with 7. Okay. That way we can exceed the LED coming off the back tail. We're uploading. There we go. Okay. So now it's turning them on. I'm going to take a closer look here. There it is. So it's turning it on, and the ones following it are dimming, 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 and then it goes to the next one, and it's dimming, dimming, dimming. Cool. Okay, so that's my Knight Rider theme here. Not too much to it, but we talk about, making something to hold the fades for each of the LEDs. Actually, let's do one more thing. So one thing I like to do is I like to make my fades logarithmic instead of linear. And that means instead of like a straight up graph, it's actually like this curve that goes up. Or I guess the curve starts up then comes down. No, I guess yeah, okay, sorry. It's like x squared. X squared starts here, goes out a little, then goes almost straight up. Okay, so let's instead of fade right here, what I'm gonna do is set a value. Okay. Oh no, sorry, not a value here. So before it does fade here, let's do an int bright equals fade. Let's see, yeah, fade a times fade a. There we go. Okay. So now it's squared, right? But we have to get it back down into like reasonable usable stuff. So we can do. I type in base. I did. That's funny. Fade a divided by equals. Where's our, there it is. Divided by equals 255. Get it back under control. Okay. So squares it and then divides it. And so now, instead of being linear, it's more logarithmic for the dimming. Okay. Let's see how that looks. Let's see if that's a little more dramatic. Let's see how that looks. Oh, that's not very bright at all. Okay, what's happening here? Oh, I know what's happening. Okay. So, an integer is not nearly big enough to hold this file or this variable, right? Because 255 times 255 is right at the edge of it. So what we can do is do a word. I'm just going to do a long unsigned. There we go. So nice big variable to hold this because we're squaring it and it's holding that into the variable, which is a lot. The fade A, that's probably simple. Okay, so now let's check it out, see what we've done. Still really dim. Okay, why is it so dim? So bright equals fade A times fade A. Okay, so at least one of these should be bright. Let's do the math here. I'm going to pull this out. So 255 times 255 equals. Oh, yeah, duh. I'm setting it to bright, not fade. Whoops. There we go. But it should still, like, it's suspicious that it's still so low. So fade A minus 8, perfect. Okay. So bright equals fade A times fade A. So yeah, there we go. Yeah, it's still dim, so it still doesn't look quite right. Fade. Oh, nope. I see. I didn't want to divide all of fade A. I wanted to just divide the bright. The bright value divided by equals 255. That makes more sense. So let's see what happens. It's compiling, it's uploading. Here comes the moment. There we go. That's a perfect fade following it. Cool. So the fade, it fades like 5 or 6 times before it moves again. And yeah, that's just a really nice like scanning light. Makes it look a lot more like the original Knight Rider. And so I'm gonna give it a little bit more of a tail, like 9 or something. Just a tiny bit. Actually, you know what? Let's see. So did I do that one right? I didn't do that right. Yeah, I did that one right. Okay. But yeah, I still didn't want to do that. I wanted to make it a lot longer. So instead of fade A minus 9, fade A minus 1. Let's see a huge tail off this. Oh, there we go. Now we're uploading. Cool. Okay. So it never even gets a chance to dim it all the way. Yikes. So you can see where it starts, but it never actually finishes. So I'm going to set the fade to -3 every time. That should at least turn them off. We'll see if it turns it off. But right now we're just playing around. We got it working well enough. I just want to. Oh, there we go. So now it's got a huge tail that's following, or that's following it. So that's actually quite a cool effect. That's about ready for Knight Rider 2. So maybe I do fade A minus like 4. Let's see if that works. But either way, this is Neopixel 120 here, Knight Rider. Just real simple, just scanning back and forth effect. We got a lot more tutorials coming up. We're gonna do lightsabers here real soon, and stuff that reacts to music, and stuff that reacts to gyros. So yeah, that's a beautiful line with it fading off like that. And so it's updating really fast, right? Like every 7 milliseconds, while the movement's updating only 80 milliseconds per. Or sorry, it's just changing the direction here, and it's moving the pix to the next one every 80 milliseconds, but the fade is every 7 milliseconds, where it actually gets dimmer, and then turns on the next one eventually. So if I were to make this really long, it would just sit there bright and then just start dimming until it got to move to the next one, then sit there bright and start dimming. Now that it's going fast enough, and the scan timer is going slow enough, now we get this cool tail at the back. Anyways, thanks for watching, guys, and good luck with your projects.